What's up, y'all? So we're gonna talk about something very interesting tonight called sports sabermetrics. So basically, congrats to WNBA champion Las Vegas Aces. AJ Wilson and the Aces did a great job beating the Connecticut Sun. I don't watch too much WNBA, though I heard about the Brittany Griner drug thing, but it's pretty fun to see sabermetrics wise how these things work. So tonight is a very short, very sweet, and very Python-y episode. That's right, I'm throwing back to Python because I had just too much Java this summer. Java was going a little overboard. So I said throw it back to Python now. So we're going to use something called Python statistics tonight to do some very basic stats analysis, and also something very cool called Kadane's algorithm. So let me show you what Kadane's algorithm basically does before I show you guys the beautiful code for tonight's algorithm 10. So let's say, for example, you have an array, a relatively easy array to work with, just 5 elements. So this is a LeetCode medium, pretty relatively straightforward algorithm regards to understanding what Kadane's algorithm does. So you have a 5-element array. So I'm going to choose the most favorite numbers I love in Boston sports: 34, 12, 0, 1, 2. So the algorithm works as following. You want to find the longest contiguous subarray sum. So essentially you have 2 pointers, one with the temporary subarray sum and one with the terminal or end subarray sum. And you'll see later in the episode when I actually code the pseudocode, this thing will work pretty well. So by running Kadane's algorithm, the largest contiguous subarray right now, which I'm going to highlight in blue, is here, 0, 1, and 2. And because it's a subarray sum, you return 3 in this case. You return 3 in this basic example of the subarray sum. So Kadane's does not work with negative numbers or work with any fractions. It works with decimal actually. So see tonight when I'm actually calculating batting averages using Kadane's, it'll work with decimal, it'll work with floating, it will not work with negative numbers. Actually, what with negative numbers? It will not work with any fractional numbers. So it has to be a whole real number in general. So without further ado, I will save this and I'll show you now the episode. So you can see we're getting pretty deep into the Algos 10 season now. And of course, this is sponsored by DraftKings, the episode. I don't usually use a lot of DraftKings, but my friend Yunjun Choi from BU Computer Science and now married to his wife Minhyun, they use the DraftKings to basically keep track of fantasy football, fantasy baseball, fantasy whatever you can think of. You know, like the adage always says, the ladies always look for, drama in Netflix and, 电视剧 and like different soap operas. The men look in drama in basically sports arguments and analytics. So unlike Stephen A. Smith, I'm not going to be ranting about the Red Sox because I know they're doing terrible this year. I'm just going to enjoy the sabermetrics with 2 other teams I bandwagon to. The Tampa Bay Rays and surprisingly the Seattle Mariners. So without further ado, here's episode 10. It's fantasy football season, WNBA finals, and of course the Aces already won, and the sabermetrics season due to both MLB playoffs about to begin in October, NBA about to begin in November, NHL about to begin in October, NBA about to begin in October, NHL about to begin in October, and NFL heating up in October. Well, you get the point. To take a deviation into some stats and nerdier stuff with algorithms with regards to sports science, we take an intro glimpse at sports sabermetrics. According to Merriam-Webster, sabermetrics is defined as the following. Detailed statistical analysis of baseball data as for purposes of evaluating player performance and developing playing strategies. Or in other words, do some cool math to determine what happens during the course of a season. So as I mentioned before, we split the episode down into two parts. Kadane's algorithm warm-up, the longest contiguous subarray LeetCode problem, and then some introduction to statistics with regards to standard deviation variance and a new way to use Python. So why did I choose Python? Because you look at this little bad boy here. I chose Python solely because you already have all the things imported. Like if you use Java, you have to like import a bunch of other libraries. It's even a nightmare in R if you import like, you know, a bunch of different R libraries. It's just a pain really. So Python's the way to go for this. So as John Denver would say from Country Roads, take me home, Stats Road, to the place where I belong. You know that great song from John Denver. That's where we want to go for tonight. It's really a segue into not only my own move out season, but we're moving on to some, you know, more niche things in algorithms now. So it's no longer just solve an algorithm or do some Kubernetes or, you know, just apply things. Now we can actually use algorithms to solve real life problems and also use statistics. This is a relatively new field in algorithms. And actually for my Optum UHG job, I use this quite frequently to like find metrics for house call stuff. So very, very important to understand stats if you're a business analyst. Low-key, I hated stats when it's back in BU and CS237, you know, probability and stats. It was like my one course in math where I really did not like. But now I'm actually starting to appreciate statistics a lot more because it not only helps my ESPN fantasy rankings, it also helps you appreciate how to do math in algorithms. So here's part one, which I'm going to show you with the now the Jupyter Notebook. So you have the longest contiguous averages feed to Major League Baseball. Sadly, the Red Sox are out of playoff contention, but I do have some friends in Seattle and while moving somewhere close to Tampa and Florida, Kissimmee, Orlando. So I'm going to bandwagon to the Tampa Bay Rays and Seattle Mariners. So here are some of the batting averages for each starting lineup in a potential ALDS or American League Division Series wildcard preview, courtesy of ESPN. For statistical significance, we round each batting average to 3 sig figs. So here are some of the stats for the Tampa Bay Rays and of course Seattle Mariners. So if you use ESPN in any way, shape, or form, or just are addicted to this application, you'll know how this thing works. They basically give you the player name, Randy Arozarena, you know, Ji-Man Choi. And you can also choose the team you want. So I chose the Rays, you choose Red Sox. God forbid you choose the Yankees. You know, just choose whatever team you want. And look at this, they have the average right here, perfectly aligned for each player. And then for Seattle, you can already tell it's more interesting. You have not only more players because Seattle has a deeper team, they also got a bunch of rookies batting 0. And you see some stars, some substitutions and stuff. So for tonight's episode, to make it super simple, we're only going to look at the batting averages. That's it. But you could apply Kadane's algorithm to pretty much anything you want. Batting average, ERA, home run. And although I don't like the Yankees that much, I do appreciate Aaron Judge going for the home run record. That is something cool to see. So we're going to apply the Kadane's algorithm, the longest contiguous subarray, to determine which lineup has the most average batting average for the MLB team. Assume we do not have any duplicate batting averages that are actually not 0. So then later time for the algorithms episode, we have part 2 for Python stats. So we're going to use the Python module statistics, which we basically use the following. Use mean, geometric mean, harmonic mean, median, mode, and quantiles. We also use variance and 2 ways to calculate standard deviation. One by just simply cheating and using this, you know, good-looking function. Another, throwing back to my GRE math, which I basically aced, is to learn how to use a very simple formula to calculate the standard deviation. And of course, give credit to Shyam's probability book for teaching me this stuff. So we're going to calculate the mean batting average, the mode batting average, the variance, the standard deviation, geometric mean, harmonic mean, and median, and the quantiles. So of course, like and subscribe to the episode. I personally will take a long break till Columbus Day, Indigenous Peoples Day on October 10th will be the next episode. So a good, I'd say 3-week break because of move out. And then hashtag #WubWubDubDub to the world of Rick and Morty and SQL database, entity relationship, and design algorithms. And yes, I am actually following up on Rick and Morty, the Solar Ricks, and the Rick Mort Well Lived, and whatever episode 3 is going to be. But please, no spoilers. I will have to unsub you if you are spoiling Rick and Morty, so be careful. So here's part 1. The longest contiguous averages feed Major League Baseball. So here's how Kadanes work. As I learned from Northeastern 5800, which is a tough algo course, you always have to start with the pseudocode. If you don't have pseudocode, good luck trying to debug your code during LeetCode. Not happening. We're basically running an ON linear time search to find a max contiguous subarray sum. So in my version of Kadane, I have a third variable called n, which is basically determining how many arrays I should look at, how much of the array should I look at. It's like a partition of the array essentially. Because you can't look at every single player in the Tampa Bay Rays and the Seattle Mariners or the Boston Red Sox. Some players might be slumping. Some players, Fernando Tatis Jr. might be doping and might be overly good, almost cheating their average with, PED drugs. And some players may just be rookies called up to, the major league because they ran out of people due to COVID. So you can't really look at the entire subarray. So what can you do? You can apply Kadanes to find out basically what's the max contiguous subarray or the most consistent subarray. Because Kadanes basically returns this a subarray sum of like the most closest to the average, like 0, 1, 2, or in batting averages, 0.300, 0.301, 0.302, and so on and so forth, all the way to 1.00, perfect batting average. So let me talk about the algorithm. I have Kadane with 3 variables, the array, the batting average looking at, and n, which is the elements. So if there are no elements, the array length is 0, or array size is 0, you can basically not apply Kadanes. Otherwise, they define a max temporary array and a max terminal pointer array. And for each element in the original array, you increase the pointer array by the element index. If the element index already is less than 0, you reset the terminal pointer. Otherwise, you continue finding the rest of the elements in the array. If no element is contiguous, then we say we reach the end of the array, and of course, return the subarray sum. So here's the thing I've been asking everybody in my Northeastern Masters. Why can't we do Kadane recursively? That is a cool application. I'm not gonna lie. It's a very, as a Cash Nasty and the people say, it's a very lit application. The reason why, because of storage space. If you apply Kadane recursively, you'll basically run in a for loop because you're always checking against the previous array. You'll eventually run out of memory. So that's why we don't do Kadanes recursively. So here is my version of Kadane's algorithm. I basically have the edge case, if n is less than 0, array equals 0, or average equals 0, just cannot apply it. Otherwise, I have the max temp, max terminal. I loop through the array, I increase by each index. And because we're looking at batting averages, we can't use 0, if you use 0.000 instead. So if max term is less than 0.00, reset the max term. Otherwise, you find for all the elements of your array, the contiguous. And otherwise, you basically reach the end of your array and you're done. And you return the max temp. So to slow this down a little bit, I'm going to do something. I'm going to annotate some stuff. And this slightly gets into some divide and conquer, actually. So this part is your init function. So you initialize stuff here. This part is where you basically, you do your loop. You do your O of n looping. And then down here, you basically have case 1. Here you have case 2. And if necessary, here you have case 3. So this is what we call a good algorithm design. A crappy algorithm design would probably make you think about, think about all the elements at the end of your array and then don't care about the beginning. Like oftentimes when solving leak code problems or like, SHA OA, where like doing these crazy hard coding challenges for interviews, you tend to think overly complicated. I learned very quickly by just even solving the simple algorithm, which is basically a very cool looking linear sort, that you can't do that. You run into some really big issues with, edge cases and some crazy stuff. So that's not going to work. So yeah, that's all for the annotations. So moving on, I apply this to my problem set. So don't worry, I reran this entire Jupyter notebook. So I have some Tampa Bay averages from ESPN. I have the Seattle averages. You could tell I have quite a bit of zeros in Seattle averages. I run it 5 times to actually build a contiguous subarray, because if you only run it once, Kadane only returns you a number, which is not really an array. And to show what I mean by the number, I partition it based on how many times I run the array. So first time I partition with the first 11 people in Tampa Bay, in the Tampa Bay Rays and Seattle Mariners. Then I, have the first 10 people, then the first 9 people, which is exactly how much you should have for a Major League Baseball lineup. Then, the 8 people. And then finally, if, everybody gets COVID and the manager does not want to forfeit, the least you can have for any baseball game, at least during coronavirus, is going to be 7 people. Because you need at least 1 DH to replace a first baseman, second baseman, or third baseman. Baseball is complicated, go figure. Next, you have Python statistics. So this is where it gets interesting. It's no longer a leak code rehash. So you have now subarrays after running Kadane 5 times, which is all the Kadane subarray sums. So you have Tampa Bay and Seattle. So here's where it's important. You have to import all the statistics modules. If you don't even import any one of them, you're going to run into errors. And that took me a long time to debug. So calculating all these stats. So mean, pretty simple, just apply mean. Seattle mean, apply mean. Mode, apply mode. Variance, apply variance. Now here we get a little more interesting. We get to some math. I know, when I first look at this formula, I'm like, am I retaking calculus again? But truthfully, no, it's not that hard. Think of it this way. When you ever look at the square root, you have to think about a graphical analysis. So you have an x-axis and a y-axis here. So I'm not going to get into central limit theory or anything too crazy, but I will draw a very simple, crappy looking normal distribution curve. Here we have the 95 percentile tails here. So I'm going to just draw 0.95. So in both my job and in, NEU algorithms and, BU probability, when you have more than 0.95, it's called statistically significant. You're trying to basically find the deviation in this range here, in this normal curve. Of course, if you want to get real fancy about it, it's the integral of a PDF, which of course gets into too much calculus. But we're basically trying to find the area under the curve here. So we first find the mean. That's pretty simple. Then for each data point, find the square, the distance of a mean. So for example, this distance and this distance, we find via this x minus x bar squared. Some people use mu, some people use different variables. I don't care. It's just basically the distance to the mean. Then you basically sum all the values from step 2. You divide by number of data points n, assuming the data is not 0, because you can't divide by 0. And finally take the square root. So we do some crazy math here. I'll save and clear all drawings. So I learned some pretty cool trick from Stack Overflow. First of all, of course, if the array is 0, array is 9, you cannot calculate at all, but you can't calculate empty array. Otherwise, you find mu to be sum array over len array, the mean. And here's a nice trick. I used a list comprehension, element times element, which is sort of, squaring it for each element in the array. Yes, I could use I could use the old approach for, element in array, sum element times element, but that's just way too costly because that is O(n) for each element, which means this thing's O(n) squared. It'll take forever to run if it's like 30 different types of lineups for MOB. And of course, then the manager gets mad and you lose your ESPN account. That's happened before to me, so I don't want that happening again. So to make life easy, I decided to use a list comprehension. Then of course you apply the formula straight up. You basically do this thing minus mu squared square root. So math nerdiness aside, here's how you run standard deviation manual for Tampa Bay, for Seattle. And of course, if you're gonna be in a hurry or you want to show off a leak low clout, which I don't recommend for interview. The interviewers I think are probably just copying off, Python libraries. Make sure you know what the math is behind the library you use. Then just use the library. As you can tell from the library, it's pretty crappy. It's way off. It's only calculating something called the popular standard deviation, which is above the scope of this episode. So when in doubt, use the math. Don't rely on Python. Finally, calculate the geometric mean, which is pretty simple. The geometric mean, the harmonic mean, and there's something called quantiles. So there's one last statistical thing I'll talk about, then I'll end the episode. You have something called a box and whisker plot. And I'll tell you now, both Python and R, this is a pretty cool statistical construct. And you have something called quartiles. So you have, 100% quartile here. So when you mention SAT, GRE grades of everybody taking a college entrance exam, and you see somebody's in the 75 quartile or somebody's in the 100th percentile, which means you're a genius to go to Harvard, or like me, I'm around the 85 percentile. It really means how much people have you actually beaten in your college examination or graduate examination score. So there's something called a box and whisker plot. This essentially helps you determine the quantiles. So in this case, the 25% quantile would just be 1.6 for Tampa Bay, 2.05 for 50%, and 3.94 for 75%. And of course, perfection is not available for baseball. So you want to draw a box and whisker, something like this. So that's the whole grid of the percentile. And now to wrap up the episode quickly, we run, Kadanes, we run Seattle Kadane. So we could get fancy with F1 score, population, standard deviation, or even high or low medians and floating point means, but that gets to be overkill. So good luck with your fancy leagues and go #GoSports Sabermetrics. One note of warning when using Python here. You need to make sure you don't have any floating NaN or weird looking, data. You always want to clean your data. Just like after you go to, after you eat your food or you dig your garden, or in this case you play baseball and your clothes get dirty. You want to be able to clean your clothes, clean your food, clean your plate and clean your garden. Make sure you clean up after yourselves when you're doing stats. That's very important. And furthermore, these are some really basic examples of how to use fractions for the statistics and decimals as well. And as I mentioned before, the mean is strongly affected by outliers. So in both the Tampa Bay and Seattle, because it's MLB averages of all the position players, it's extremely easy to see statistical errors and outliers. If it's more like a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, easy, best case contiguous subarray for Kadane, that's not going to be a problem. So see you guys in the Florida area when I go to, talk about Rick and Morty and Wubba Lubba Dub Dub. And of course, if you've not yet, like and subscribe. Thank you very much. It's Jason Liu, Algos in 10, Season 3, Episode 10. And of course, congrats to the Aces again. And hopefully, the Celtics do better this year. Thank you. Bye. And do not forget to also give DraftKings a look. If you're over the age of 18, it does not allow you if you're under 18. It's a legal policy from the website. See you guys later. Bye.